All right, here we go with our Introduction to Calculus, Lesson 4. This now puts us into Chapter 23 of the textbook that we're using. But here's where we really start to approach the need for calculus, as we've been talking about slope, or you could say gradient, or you could say the average rate of change. Well, in the graphs that we have always dealt with, that you've always dealt with before calculus, slope was always found through something that was linear. So it was a straight line. And anytime you have a straight line, the slope is constant. It never changes. So if you pick any 2 points on the line and find their slope, you'll get the same slope every single time. This is one that we had just looked at a couple lessons ago, but within this line you can see, right, that because it's linear, the slope is constant. So if I were to pick this point and find the average rate of change, it would be the exact same answer as if I were to pick, say, this point and this point, right? Any 2 points I use, when I put them into the slope formula, I'm going to get the same slope if it's a line, because my slope is constant if it's a line. But that changes when your graph is no longer linear. So if we have a graph that looks like this, so now when I go to find my average rate of change, it will vary. Even though I'm using the same graph, if I use a different set of points, I'm going to get a different slope, because everywhere on this curve I'm constantly getting different slopes. The slope right here is different than the slope right here, and that's different than the slope over here, and so it's always changing when your graph is no longer linear. So we're still using the slope formula right now. What we're seeing on this one is if I wanted to get the average rate of change, or the gradient from the graph from where x is -3 to where x is 1, and so on this one, so again, these are just x's, so they're saying that x is -3 on the first one, and then x is 1, and so I'm actually going to pull the y coordinates from the graph. So where x was -3, you can see, I already got those dots drawn in. The y coordinate at that point is 1, 2, 3, 4. So that's just this point right here we're seeing is -3, 4. And then where x is 1, you can see right here, my y is 1. And so we have those points, and so I'm still going to plug those into my slope formula, and I'm still getting an average rate of change. So let's do that real quick. So if I did my y minus y over x minus x, looks like I'm going to get 3 over -4. So my slope, or I should say the average slope, from all of the slopes from this point all the way to this point is -3/4. Of course, if I drew a line directly from this point to this point, well, then the slope of that line would also be -3/4. And so again, it just represents the average of all the slopes from here all the way to here, all those slopes. If I added every slope together and divided it by however many that is, I would get -3/4. One thing to keep in mind is, in general, when we use our slope formula, we typically see it as y minus y over x minus x. But keep in mind, that in a function, right, we often don't see y written. We see it instead as f of x. And so really, the way that we're going to have to get used to seeing this is f of x minus f of x, which is the same thing as having y minus y over x minus x, right? And so what we just did was, for the first one, I plugged in -3 and came out with 4, right? And so we said f of -3 minus f of 1 over x minus x is -3 minus 1. And so I always mention that because this is going to help as we get into the tougher things as we move forward here in the next couple lessons. But this is kind of how we always want to view what we just did. And so again, in order to get this y coordinate, I got that by plugging in -3 for x. So we would say f of -3 is 4. That's what it came out to be as a y value. So moving on, just doing the next couple. So same idea on these guys. These are my x's, -3 and 8. And we're just going to use the graph to get some y coordinates. So -3 we already noticed gave us a value of 4. 8, if we took a look at where 8 is on the graph, 1, 2, 3, 4, 5, 6, 7, 8, and trace that one up and over, you can see that one is also at 4. And so what happens when you have a horizontal line, the slope of that horizontal line, so if I did y minus y over my x minus x, all right, notice I get 0 on top, so we have a 0 slope. And another one of those biggies that'll kind of keep coming back is understanding that the slope of 0 always represents a horizontal line. And again, in terms of this graph, if we talked about average rate of change, we're saying if I were to take all the slopes from this point and all the way to this point, I took the average of all those slopes, the average of those slopes would be 0, is what we're getting for that one. So last one on these, so from 0 to 2. Again, those are my x's. So at 0, we can see on the graph is right here at -1. And at 2, it is 2. So again, one last time here, we'll do y minus y over x minus x. And get our slope. So again, slope, also known as average rate of change, that we're getting on this graph. We can get it from the graph. That's what we were just doing in the first couple examples. We can also get it from a formula. And so instead of plugging in x's into the graph to get some y values, now we're going to plug them into a formula. And so we would say, what is f of 1? So I need to plug in a 1 to see what I get for that one. I also need to say, what is f of 3? And plug that guy in to see what I get. So if we plugged in a 1, 1 squared plus 1 over 1, that's like saying 1 plus 1 is 2. Plugged in a 3, I would have 9 plus 1/3. So for now, let's just call that 9 1/3. And so the x's we plugged in were the 1 and the 3. These were the y values that came out of this. And again, remember, we're doing average rate of change, which is slope. So again, the notation I want you to get a little familiar with here is we are doing f of 3 minus f of 1. That's like saying y minus y over x minus x, right? Those were the x values. We know that f of 3 is 9 1/3. And we know that f of 1 is 2. And then from there, you're just going to go, I would just go to the calculator and clean that up. Probably leave, you can write answers as fractions or decimals, but I would do the rest of that in the calculator. Same thing that we're going to do on this next guy. So I'm going to plug in the 3 and the 8 as my x's. So I'm going to plug those in for this guy and for this guy in order to get their y values. And then I'm right back to doing y minus y over x minus x. And so we can follow the rest of that. It's not going to be a whole lot different than the one that we just did. On something like this, we probably just go decimals because of the square root as well as the exponent. So this is just going to become a calculator problem, and we'll just use decimals for something like that. Just a quick hint that I threw into these notes for the assignment that will follow this was when they say something like during the first hour, right? That means they're giving you an interval of x's from 0 to 1. So just like we were doing up above, that means my x's are 0 to 1, and I would be plugging those in to get y coordinates to go with them. Or if they said during the first 3 hours, that would be the interval from 0 to 3. And again, those would be my x's. I'd be plugging those in to get some y coordinates.